we're just doing day 2 of conics, and we want to compare and contrast these two equations. So they look similar, where we've got the 4 is underneath the x on this one, the 16 is underneath the y. But this one, the 4, is in the same place as this one is, only it's with the y instead of the x. So how come this one right here is wider here? How come this one's wider here, right? And then this one's wider here. Okay, we should raise your hands. All right, let's hear it. Okay, so you hear that? The amount on the y is larger on this one, but the amount that's associated with x is larger on that one. Okay? What happens when I've got that y squared out in front instead of x squared? Why is that? Does anybody see it? Why is the y squared in front instead of the x squared on that one? Again, guys need to raise your hands. Okay, let's hear. It lets you know that your hyperbola is going to have vertical branches. See those vertical branches there? All right, let's see what else I've got in here. Oh, we already did our scavenger hunt. This is what you probably want in your notes, right? Did anybody put this in their notes yesterday? We ask ourselves, x and y are both squared. If they're both squared, we keep going, right? If they're not, we know it's a parabola. Here's an example of that. So we have y equals x squared. That's only one being squared, and that looks like this. Or we have x equals y squared, and that one looks like this. Correct? All right, so let's say they both are squared. Do x squared and y squared have the same sign? So if they have the same sign, we keep going. If they don't have the same sign, we know it must be a hyperbola, right? Because hyperbolas have a negative sign. Over a over b equals 1. They have that negative sign right there. So that says, do x squared and y squared have the same sign? Y squared has a different sign, it's negative. Do x squared and y squared have the same coefficients? So if they don't, we have an ellipse. If they do, we have a circle. So an ellipse would be x squared plus y squared over a and b equals 1, but on a circle, it looks like this. A circle has x squared plus y squared equals 1 over r squared. They're both r squared, or the r could be on the side, but they're both the same. The major and the minor axes are both the same, so we don't need to say either one of them is major or minor. We just call it a radius instead of an axis. Okay? All right, does anybody still need this up? Okay, I'll leave this up for just a second for your notes. Okay, so let's do number 1. All right, I'm going to make this a lot smaller because I want some room. I want it up there because I want to reference it. Okay, because I'm going to ask myself, are x and y both squared? X squared and y squared. So this can't be a parabola, right? Do x squared and y squared have the same sign? This is positive, this is positive. They have the same sign, so it can't be a hyperbola. Do x squared and y squared have the same coefficient? This one has a coefficient of 4. This one has a coefficient of 1. They do not have the same coefficient, so therefore this must be an ellipse. Do you see that? If they had the same coefficient, it would end up being a circle. All right, so I'm going to go ahead and work with just the x's first, which some of you guys have been doing. So I have 4x squared minus 40x. Do you see anything else up there that has x's? No, so we're going to add something. I'm going to leave this for now because I've got a coefficient here. I'm going to have to pull that coefficient out. So let me just leave that for a second. Then I've got y squared negative 6y all equal to negative 93. I take care of everybody? Okay, perfect. All right, so now I need to take that 4 out. So when I take that 4 out, I have to remember that I've got a factor of 4 on both sides that I'm going to be adding. And you'll see why in just a second. So x squared, when I take a 4 out of negative 40, I'm left with negative 10. I'm going to add something to both sides. But when I add something to both sides, I have to remember that 4. So I'm going to add 4 of whatever I have. Okay? Hold on. Then I've got plus y. I don't need to factor anything out. Thank you. Minus 6y. Plus I'm going to, let me make this a little bit smaller so I've got room. Plus 6 squared minus 6y plus something. And I'm going to have to add that something also to the other side. So what goes in here? Half of 10 is negative 5. So this is going to be negative 5 squared. Negative 5 squared is 25, correct? But I'm not adding 25 to both sides. I'm adding 4 times 25. So it's going to be 100. Then over here, I have half of 6 is 3. So that's going to be 3 squared. Sorry. It's going to be 3 squared, which is 9. So now I can make my perfect square trinomial. I've got 4 times x minus 5 squared plus y minus 3 squared equals negative 93 plus 100 is going to be positive 7. And 7 plus 9 is 16. So when I divide both sides by 16, that's where I've got, that's where this turns into my ellipse. The 4 and the 16 cancel each other out. So I have x minus 5 squared over 4. Over 4. And I have plus y minus 3. There's nothing to cancel here, so it just stays 16 is equal to 1. So the most important part is when you've got a coefficient here, right, you've got to remember that you've got to add it over here as well. That's the only, like, more complicated part of this. So let me make sure you guys have all that copied down and you guys keep going. Okay, Michelle, what was your question? Oh, thank you. Appreciate it. I just didn't want to stop our thinking. Yes. Yes. So there's a real good example for you to begin with. You should be able, as you're doing these, you should be able to start looking at it and asking yourself these questions. You should be able to tell me what type of conic it is without even doing any of the work. Okay? Yes, Christian. Okay. Because if there's if it's the x squared's in front, it's horizontal. If the y squared's in front, it's vertical. Yeah. after it's the 7-minute bell already. Yeah. Okay, I forgot I was recording. Are we good? I think I'm done with the recording. That's probably good enough.